Hello, welcome to my channel Deep Learning Biology. My name is Dr. Vikas Bhardwaj, and within this video we are going to learn about standard Gibbs free energy. We are going to learn what is standard Gibbs free transformed constant. Okay, these two things we are going to learn and we are going to discuss. Okay, important point related to this. Okay, now here hopefully you know what is Gibbs free energy, and if you don't know, please have a look into my videos. We have discussed a lot about Gibbs free energy, and in this video I am going to teach you what is standard Gibbs free energy and what is this standard Gibbs free transformed constant. Okay, now try to see here. Okay, let's suppose there is a reaction. Okay, A is going to react with B. Okay, and what we are going to see, formation of C and D. Let's suppose this reaction is also occurring in reverse direction, and here A and B, they are reactant, and C and D, they are product. Okay, now hopefully you must have learned in your chemistry class, okay, how to calculate the K equilibrium. Okay, so equilibrium constant can be calculated. What is that? Concentration of C, concentration of D, concentration of product divided by concentration of A, concentration of B. Okay, so here by this way you can calculate this K equilibrium. Okay, this is known as equilibrium constant. Okay, so here you see it is going to be a constant. Okay, now here if you see that we have to discuss about standard Gibbs free energy. Okay, now hopefully you know what is delta G. Delta G is change in Gibbs free energy. Now here you see if this reaction is going to occur at standard condition. Okay, now what are these standard condition? Means that your reactant, okay, they are present at a concentration of 1 molar. Okay, and the product is also present at a concentration that is 1 molar, and pressure is 1 atmospheric pressure. Okay, and the temperature is standard, that is 25 degrees Celsius, and if you calculate it in Kelvin, okay, it will be 298 Kelvin. Okay, now the same reaction, okay, if you are going to perform at standard condition, means you are going to take the concentration, okay, of the reactant and product. Okay, you are going to start with 1 molar of each, and pressure is 1 atmosphere, temperature is this, and if you are going to calculate the value of delta G. Okay, so when you are going to calculate the change in Gibbs free energy at standard condition, then we use this here note. Okay, so here you can use and calculate this by using the relation minus RT, okay, ln K. Okay, so here you see R is gas constant, okay, then T is temperature at which you are going to carry out the reaction. At standard condition you are going to carry out at 298 Kelvin, and this is K is your equilibrium, okay, constant. Now here if you are going to calculate the value of this change in Gibbs free energy, okay, and this is going to be known as change in free energy at standard condition. Okay, so these are the standard condition. Now here I just want to tell you, keep in mind, okay, yes, in a test tube you can have standard condition, but keep in mind within the cell, okay, you are not going to see the standard condition. Okay, so here we are going to use some different biochemical standard condition. And what are those? Okay, so the first thing is that if you see in the case of chemistry, generally the hydrogen ion concentration, okay, it is here what we are going to take 1 molar. So when you are going to calculate the pH, okay, of hydrogen ion concentration 1 molar, and you know pH is equal to minus log of hydrogen ion concentration, okay, and if you solve this, it will come out minus log of 1, it will be 0. Okay, now try to see here in case when you are going to have cell, okay, within the cell you are going to have generally the pH that is 7. Okay, so we are going to take this as the standard. Okay, so here in biochemical standard condition you are going to take the concentration of hydrogen ions as 10 to the power minus 7. Same way here you are going to have the water concentration, okay, that is 55.5 molar. Okay, pure water is going to have this molarity. Okay, in any another video I will tell you why this value is 55.5 molar if you don't know. And here if you see the magnesium ion concentration, okay, it is 1 millimolar. And in this situation if you are going to calculate the value of delta G, okay, then we write it as prime note O, or you can write like this delta G O prime. Okay, you can write anyway. Okay, and you are going to calculate the value minus RT ln K equilibrium. Okay, so this value, okay, this one, now it is known as standard transformed constant. Okay, so the value of change in Gibbs free energy at standard cellular condition. Okay, standard cellular condition means pH 7, okay, concentration of water 50.5 molar, magnesium ions 1 millimolar concentration, okay, that is known as standard transformed constant. Okay, so hopefully it is clear to you what is this, okay, value. This is standard Gibbs free energy change, okay, at the chemical level, okay, and here this is at the cellular level. Now here I just want to tell you, okay, let's suppose here if the value of K equilibrium, okay, it is equal to 1. Okay, let's suppose if the value of K equilibrium is 1. Okay, now you are going to calculate delta G prime naught O. Okay, it will be minus RT ln 1. Okay, now if you solve this, it will come out 0. Okay, now here what you are going to see, delta G prime naught O is equal to 0. Here you can say that reaction is at equilibrium. Okay, the reaction is at equilibrium at standard biochemical condition. Okay, and here you must keep in mind, if the value of K equilibrium is greater than 1, then your delta G prime naught O value, it will come out negative. Okay, so in that situation the reaction is spontaneous. Okay, so we are talking about this standard condition, reaction is spontaneous at standard, okay, cellular conditions. Okay, then if you are going to have this value of K equilibrium, it is greater than 1. In this case, keep in mind delta G prime naught O, okay, it will be positive. Okay, now in this condition, what is going to happen? The reaction is non-spontaneous. Okay, hopefully you know what is spontaneous reaction and what is non-spontaneous reaction. Okay, but this is non-spontaneous at standard cellular condition. Okay, so hopefully all these points are clear to you. Now here I just want to tell you that the relationship between delta G prime naught O and this K equilibrium, okay, it is exponential. Okay, so you are going to have exponential relationship between them. Okay, so what is going to happen if by chance there is small change, very small change in the value of delta G, what you are going to see, you are going to see a big change in the value of K equilibrium. Okay, so this point you must keep in your mind. Now we are going to discuss another point here, that is actual free energy change. Okay, actual free energy change. Okay, now you can calculate this by using the relation delta G is equal to delta G prime naught O plus RT ln K equilibrium. Okay, now we are going to calculate what is this actual free energy change. Try to see what is actual free energy change. Okay, now here keep in mind this delta G prime naught O, this is going to be constant, okay, for any reaction. Then here if you see this value, okay, this RT ln K equilibrium, okay, it is actually the function of, okay, concentration of reactant, the concentration of product, and it is going to depend on the temperature. Here you only one constant is there, that is the gas constant. Now keep in mind, okay, this value delta G, okay, the actual free energy change, it is not going to be constant. Okay, this is going to vary, and hopefully you remember, if the value of delta G is equal to negative, in that situation the reaction is spontaneous. Okay, if the value of delta G is equal to positive, the reaction is non-spontaneous, and if the value of delta G is equal to 0, the reaction is at equilibrium. Okay, now here if you look into this equation, okay, this one, let's again we can write, okay, delta G is equal to delta G prime naught O plus RT ln K. Now here you can say, and you can see this value delta G prime naught O, okay, it can be positive, it can be negative. Okay, same way this can be positive, this can be negative. Okay, based on your calculation. And try to see here, let's suppose you are going to have this value delta G prime naught O, okay, you are going to have the value 10. Okay, and let's suppose if you calculate this value, it will come out minus 15. Okay, then if you are going to calculate delta G, it will come out 10 minus 15, 5. Okay, so it will be negative. So means if you are going to solve this and if you are going to get the negative value, then you can say reaction is spontaneous at actual condition. Okay, now here keep in mind, for any reaction, okay, delta G is going to decide, okay, whether the reaction is going to proceed in forward direction or reverse direction. Okay, not the value of delta G prime naught O. Okay, so this is going to tell you whether the reaction is spontaneous or non-spontaneous at standard condition. Okay, but this is going to tell you whether the reaction is spontaneous or non-spontaneous at actual condition. Now here I also want to tell you one important point. Keep in mind that if the value of delta G is equal to positive, okay, the reaction is going to be non spontaneous, means it is not going to occur in the forward direction. Okay, let's suppose there is a reaction, A is being converted into B, and let's suppose for this reaction the value of delta G is equal to positive, means that reaction is non spontaneous. And keep in mind, even if you add any enzyme to this reaction is not going to proceed in the forward direction. Keep in mind, enzymes, okay, they do not change the value of delta G. Okay, so whatever the value of delta G is there, it is going to remain same. Okay, and if the value of delta G is positive and if you add the enzyme, that reaction is not going to proceed even in the presence of enzyme. Keep in mind, enzymes, they do not change the value of equilibrium constant. Okay, they do not change the value of delta G. Okay, so hopefully you have learned many things about change in Gibbs free energy, and in this video we have already discussed what is standard change in Gibbs free energy and what is standard transform constant. Okay, so this is about Gibbs free energy, and hopefully you have learned completely each and every minute details, okay, related to Gibbs free energy. Hopefully you are going to like the video, okay, you are going to share the video, okay, and you are going to subscribe to my channel, okay, Deep Learning Biology. Please, if you have any difficulty, please let me know. I will happy to answer. Thank you.